All right, these are your notes about the electromagnetic spectrum. So this is the electromagnetic spectrum. So just to review, electromagnetic waves are transverse waves that do not need a medium to travel. So just remember, electromagnetic waves do not require a medium to travel. They can go through a medium like air and liquid and solids, but they don't have to. This makes them unique because electromagnetic waves can travel in space or an empty vacuum. The energy that the electromagnetic waves transfer is called radiation. Now, radiation can sometimes sound like a scary word, but radiation just means electromagnetic energy. Some is good, some is bad, but it just means energy. So it's not something that we should really be scared about. So let's see, here we go. So here is the electromagnetic spectrum. I'm actually going to show you a bigger picture here in a minute. But the electromagnetic waves have a wide range of wavelengths, frequencies, and energies. We arrange the spectrum according to wavelength. So long wavelength to short wavelength, this is how we get the electromagnetic spectrum. There are 7 total electromagnetic waves: radio, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma that are on the electromagnetic spectrum. They go from the longest wavelength of radio waves. They get shorter and shorter until they get to gamma waves, which have the shortest wavelength. Radio waves also have the lowest frequency. Remember, frequency means that they are less waves per minute or per second, and they have very low energy here. So low frequency, low energy, long wavelength is the relationship between those. I just think of it, they all have L's, okay? Low energy, low frequency, long wavelength. The shorter the wavelength gets, the higher the frequency gets, mainly because the more waves per second you can fit. The higher the frequency, the higher the energy. So we're going to take a look at each of these 7 waves in detail and talk about what they are, how their wavelength and energy and frequency go together, and then give you some examples to go along with them. All right? So the first one we're going to talk about is called radio waves. Radio waves have the longest wavelength, which means they have the lowest frequency. So if the wavelength increases, meaning gets longer, then our frequency is going to decrease. That's our relationship there. Longer wavelength, lower frequency. This also means they also have very low energy. Some examples of these are our radio waves, our FM and our AM radio. Now, it's not the sound that comes out of them, but it's the radio signals that we get from satellites in space and around our country where the radio waves are being broadcasted. Our TV signals work the same way, and so do police radar guns. So police radar guns, like the guy down here, they check your speed by sending out a radio wave to your car. That radio wave then hits the car and bounces back. It's called reflection, and it gives the cop your speed of your car. So they use radio waves, which are a safe type of radiation. So even though the cop is shooting radio waves at you, you're not even going to know it. You can't see them, you can't feel them, you're not going to be affected at all. It's just going to reflect back to him and get the speed. So radio waves are safe, and they're our first wave. Moving right down our spectrum, we get microwaves. Microwaves are our second longest wavelength, our second lowest frequency, and our second lowest energy. Microwaves, of course, are our microwave oven, but are also our cell phones use microwaves. So microwaves is a safe radiation. There are many studies about cell phones and lots of use of microwaves, but they are a safe radiation. So we use them in our cell phone signals, and we also use them in our microwave ovens. So those are microwaves, our second wave. Infrared waves get a little bit more interesting. So infrared rays are the energy that you feel as heat. So again, we can't see these. So far, none of these waves we can see. These are waves that we feel as heat. These are the third longest wavelength, our third lowest frequency, and our third lowest energy. These are things like heat lamps. The TV remotes use heat infrared rays to send signals. Special night vision goggles or FBI, SWAT, police, they use thermographs, which is a picture of heat, to see if there's anybody in like houses or to see how many people are in there if they're going on a raid. So we can see those using a special camera, but we cannot see heat waves with our naked eye. So those are infrared waves. So far we've talked about 3 waves that have a long wavelength and low frequency and low energy. These are the safe rays. The one directly in the middle is the only one that we can see. So the one directly in the middle is called visible light. This is the only electromagnetic wave that we can see. It's our middle of the spectrum, which means it has the middle wavelength, it has the middle energy, and middle frequency. This is also where we get our colors, which you'll get more of that in a later podcast. But our colors are also in this order, Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet, because of their wavelengths. So remember, the electromagnetic spectrum is all arranged by wavelength. So red has the longest wavelength of all the colors, whereas violet has the lowest wavelength of all of our colors. Let me just move that out of the way there so you can see that. Okay, so that's why our colors go in that order. They go from the lowest energy to the highest energy based on our wavelength. So visible light are the only ones that we can see. So we can see because of the visible light spectrum. So we get color and sight from this. Moving away from the middle, we're now moving into our shorter wavelengths and our higher energies. So the next 3 are actually dangerous to us. So the first of the 3 is called ultraviolet rays. We're going to call these the 3rd shortest wavelength, the 3rd highest frequency, and the 3rd highest energy, which makes these the 3rd dangerous for us. Now, ultraviolet rays, or UV rays, we get from the sun. Some sun is good for us. Too much sun might give you a sunburn, which is not very pleasant. Really, really too much sun could give you skin cancer. Really not good. This is also used in black lights and in sterilizers. So hospitals and dental offices and other places that create sterile equipment uses UV radiation to kill all bacteria and germs. So in order for us to kill viruses off, we need a lot of ultraviolet radiation from the sun because that kills germs, bacteria, and viruses. So the sun is good, but too much of it can be harmful, such as skin cancer and sunburns. So be careful with those, but we need those. The next one we're going to talk about is my favorite. It's the X-ray. X-rays have the second shortest wavelength, the second highest frequency, and the second highest energy. That means they're the second dangerous waves. X-rays are so dangerous that they can actually pass through skin and soft tissue, but they are not powerful enough to go through bone or lead, which is why when you get an X-ray, say at the dentist office, they cover you with that really heavy lead blanket. That's to protect your other organs from being radiated. Now, again, we cannot see X-rays with our naked eye, but we can see an image formed by the reflection of the X-rays off of whatever we're looking at. That's why medical professionals use X-rays to diagnose different medical problems. So these X-rays, this is why these are my favorite. These are my X-rays I've actually taken myself. I used to be an X-ray technician for a veterinary office before I became a teacher. So these are actually all images of dogs. So usually you have to go to special school to learn how to read these things. You're going to get a veterinary lesson right now. So on an X-ray, everything that shows up as white is stuff that X-rays reflect off of, meaning they can't pass through. So bone and metal show up as white. Anything that shows up as black is either a gas or a liquid. So this dog here is on its back, and we're stretching out so we can see its abdomen because this dog came in not feeling too good, not eating, throwing up, and just generally just bleh. So we can see here that there's 2 black triangles right here. These are the dog's lungs. So they're black because they have air in them. The thing in the middle, you guessed it, that's the heart. You can see the rib cage here, and you can see the spine. These are our pelvic region and our legs. So in here, this organ right here is our stomach. this kind of like triangle shape right here, this is a liver. All of these like worm looking squiggly things, that's the dog's intestines. And this dog is actually full of poop, which is what you can see here in the little gray specks here. But that's not the dog's problem. The dog's problem lies right here. So there's a round metal piece right here in the stomach. We know it's metal because the x ray can't go through it. This dog actually came in because it swallowed a coin. We didn't know that at the time, but as soon as we took the x ray, we were able to decide that yes, it swallowed a coin and we had to go get it out. But the dog's fine. We called it a puggy bank. It was a pug. I'm going to skip the middle one for now. This dog came in because it was limping. So we took a picture of its leg. Here's his foot, and here's the leg, and you can clearly see the problem here. The dog broke his leg. So x-rays are a very valuable instrument for the medical field, but they are pretty dangerous, which is why I had to wear a special suit and a badge to monitor how much radiation that I was being exposed to. But they are pretty good. So back to this middle image, I actually blew up a picture here. So this dog, and normally if I was live with you, I would have you guess what's wrong with the dog. So you can be guessing at home until I tell you. But this dog is on its side here. So we have a spine. This is its tail. And these are its legs. And these are its rib cages. That's our liver in here. And this is the abdomen. Okay. Not necessarily the stomach, but the abdomen. And inside, you can see that we see a lot of like looking like little ladder things. Most of my students typically say that it eats bones. This dog did not eat any bones. This dog is going to be a mommy. So this dog is pregnant, and these are all the puppies inside its belly. Now, typically, we don't x-ray pregnant women, human women, because it is harmful to the baby. But with dogs and cats, they have more than one at a time. So it's really important for us to count how many the dog is going to have in case there's complications. So this dog, we count the skulls and the spines, and there are actually 6 of them in here. So this dog was pregnant and had babies. So we just counted how many they were. Okay. All right. The last wave in our electromagnetic spectrum is called the gamma ray. Now, gamma rays you probably heard of because of the Incredible Hulk on Infinity Wars. The Hulk was created because he was exposed to a high amount of gamma radiation. I do not suggest that it will kill you. That's because gamma rays are the most dangerous of all the electromagnetic spectrum waves. They have a short wavelength, a high frequency, and the highest energy, making these the most dangerous. Gamma rays can penetrate through anything, skin, tissues, and they're so penetrating they can actually destroy the DNA of your cells, which is why they're extremely dangerous. But medical professionals have actually used these to cure and be good. This is what people use to kill cancer cells. Because they do kill cells, it's good to kill cancer cells. Unfortunately, you also kill normal cells. So that's why people undergoing cancer treatments are so susceptible to disease. These are also used for our CAT scans. So they can use a CAT scan, like the one in the picture here, to get images of your internal organs and your brain functions. But on the bad side, they're also used for nuclear reactions and nuclear weapons. So really dangerous, could be used for good, could be used for bad, kind of a toss-up. But those are all 7 ways of the electromagnetic spectrum. You do need to be able to compare and contrast them if given a diagram and know the order of them. So I will show you the picture again to kind of show you the order of our waves. The easiest way to remember our order is to remember that visible light goes in the middle. The first color of our rainbow, hopefully you guys all know that, is red. So the wave that comes right before red is called infrared. The last color of our rainbow is violet. So the wave that comes after violet is ultraviolet light. So you have 3 right in the middle that you should already know. Just remember that radio is the first, gamma is the last, and then you can stick the other 2 in just by process of elimination. So that's your electromagnetic spectrum.